Assalamu alaikum everyone. Today I will represent about containerizations, which is the Docker deep dive. In this presentation, I will talk about introduction to containerizations, history and evaluations, Docker architecture overview, Docker command summary, and Docker volumes and networks. And then, first of all, what is containerizations? Containerizations is a method of packaging an application with all its necessary code, libraries, and dependencies into a single isolated environment called a container. This ensures that applications runs quickly and reliably across different computing environments from a developer's laptop to a cloud server. In the traditional virtualizations, each virtual VM includes a full guest OS, heavier slow to start and higher resource overhead. And containerizations is DevOps and clouds. Containerizations is a fundamental to modern software development, especially in DevOps and cloud environments for several key reasons. First one is consistency and portability and scalability and efficiency and micro services and support. Why containerization is essential? It is essential for speed and agility, which is the rapid development and scaling in cloud environments. And DevOps integrations ensure consistency from development to production. Resource efficiency. Lower infrastructures cost due to shared kernel architecture. And then history and evolution of containers. From early concepts to the modern Docker ecosystems. And first one is early tech Root in 1979 and FreeBSD jails in 2000 laid the groundwork for isolations. And second one is LXC in 2008. Linux containers provided OS level virtualizations. Third one is Docker Origin in 2013. Evolved from an internal project into a simplified interface. And the last one is open source and growth. Rapid adoption and standardizations becoming crucial for modern software development. And then the Docker architecture overview. Major components of Docker is Docker Engine, Daemon, Docker CLI, Docker Hub. Docker Engine is the core part of Docker that builds, runs, and manages containers. And the Docker Daemon is a background service that handles container operations like building images, running containers, and managing networks. Docker CLI, that means command line interface, a tool that allows users to interact with Docker through commands. And the Docker Hub, a cloud-based registry where Docker is images are stored and shared. And the image and containers, the foundation. To truly understand the containerizations, you must grasp the difference between an image and container. On the left, we have Docker images. Think of a Docker images as a read-only blueprint or a sealed-up package. It is a static file containing your application code, its libraries, and all dependencies. Importantly, images are built from a simple text file called a doc file. On the right, we have Docker containers. The containers is the running instance of the blueprint. When you execute a image, you create a container. This container is a live, isolated, and highly portable environment. It includes a writable layer of temporary data, but fundamentally, every time you start a container from the same image, you get the exact same consistent result. And the essential Docker commands. Docker run, which is a create and start a container from an image. Docker ps. List running containers. Use for all. Docker images. List local Docker images. Docker pull. Fetch an image from a registry. Docker build. Build an image from a Docker file. Docker Run a command inside a running container. Docker stop. Gracefully stop a running containers. Docker RM remove a stop containers. Docker logs says the logs of a containers. Docker inspect return detailed low-level information on Docker projects. Data persistence, which is the Docker volumes. Containers are ephemeral volumes ensures data survive container lifecycle. Persistent storage for container data, decouple data from the container's writable layer, easier backups and migrations used for database and stateful applications. The container communications, which is the Docker networking. Breeze, default network for single host containers, isolated private network. Host, container shares the host network stack, no isolations. None, container is completely isolated from the network. Overlay connects containers running on the different Docker hosts. Thank you all.
Open the terminal and log in, and then install Docker engine. Update install prerequisites sudo apt update and sudo apt install হয় সেই certificates called genevg lsb release done. Then add dockers offline official jpg key and repository. The commands are http download docker.com linux ubuntu jpg sudo jpg dearmore etc apt keyrings docker.jpg. Then echo dev arc dpkg print architecture signed by etc apt keyrings docker.jpg https download https://downloads docker.com linux ubuntu. Then lsb release cs stable sudo t etc sources list docker dev null. Done. Then install Docker engine and release packages. Oh sorry, something error, and solve the error. Linux ubuntu lsb release stable sudo t etc apt sources list dot docker dot list dev now. Done. Then install Docker engine and related packages. Sudo apt update and sudo apt install or docker cli container.io docker plugin docker compose plugin. Oh, here is error. Solves the error. Okay, done. Installing is ongoing. Take a few seconds. Okay, done. Then check Docker version. Okay, done. Take a screenshot and then go to the website then sign up. Docker website, here the username, then sign up the Docker app. Yes, done. And then create a Docker Hub account and log in. Go to the website and input the on-time code. Yes, here is done. And pull the images. Take a screenshot first and then Docker pull nginx. Here is something happened. Solve the problem. Okay, done. Downloading the nginx completed. Docker pull MySQL. Yes, done. Downloading. The Docker pull ready is downloading. The Docker pull Mongo downloading. Wait for a minute. Downloading is ongoing. Okay, done. Then download full HTTPD. Downloading, done. Then pull the images, Docker images. Okay, done. Then create and run containers. Docker run the name my nginx p8080 nginx. Then run Docker name my Apache 8081 and check the containers and then test the browser. Then create a volume and run. At first take screenshots and create a volume and run MySQL using it. Docker volume create my data. Run the MySQL root password root for example. And inspect the volume and host path. Done. Then output includes mount points. Host path may be slightly. You can erase that path using sudo to C files. The Docker list the networks and create custom network and run containers on it. MySQL root password root MySQL. Then verify the containers are attached. Docker network inspect MyNet. Then test the connectivity between containers using ping or connecting the update dev null apt get install ping dev null ping say 3db or use simple card if there is a service. And the better pattern, use a small busybox containers to ping. Take a screenshot. And useful management commands. Docker to my nginx, my Apache, MySQL, DB, and then remove containers. Oh, sorry, error. And remove the images. And thank you all.